What's going on, y'all? Today, someone has shot across the bow. They are talking mad shit. Somebody out there claims that there's a programming language out there better than Go. Now, I will not stand for this. In fact, I am sitting down right now. I am ready to take these people on. And there's nothing they can do to stop me. You know what? I'm not going to do the long intro. I'm not going to wait for him to show up. Forgot to turn on my camera. Hold on. This has gone on for long enough. There's a program out there called, or a library called Atacama. There's an OCaml socket pool for Riot. I don't know what that is. But what I do know is that they claim in this benchmark thing that Go is slower than Rust, Elixir, Erlang, EU, and Atacama. This is unacceptable. So what I've done is I've recreated their benchmark for Go. And frankly, whoa, real quick with the subscribe. Whoa, Jordy, 3 months. Wow, appreciate it. Small Moose is reacting with the old, good stuff. Thanks for the subscription, Jordy. Appreciate it. Anyway, what was I saying? Yeah, some nonsense. They're saying that this thing works this way and whatever. I looked at it over 10 seconds. Yeah, it's pretty comparable. You know, my computer's I guess a little bit faster, whatever, but like 191 to 220, aggregate bandwidth 11040, 995, 96, whatever. So these numbers are comparable. But my goal today is to make this number go down or up. I want this number go up. So our goal to beat is 220. I'm going to make a new sticky. So open up stickies. Delete note. Initial results over 10 seconds. And I'm just going to paste that in there. So our goal is to get this down to, I don't know, 1/100th of what it currently is, or 100 times what it currently is, 1,000 times what it currently is. I want to beat this number. Now, I'm not going to install Atacama on OCaml to do it, but I'm going to beat this number anyway. So the first thing to do is to look at the code. Let's just see what we're dealing with. This is called echo.go. Okay, import IO. So let's do one of those real quick. IO, FMT, net, and OS. All right, this makes sense. L comma air equals net.listen TCP 2112. Okay, so we're listening on TCP on port 2112. That's all fine. Defer stopping of listening to that. That's fair enough. So now it just loops, and then it accepts a connection. If there's an error accepting it, exit, and then we'll go handle the request. Okay. So let's check this handle request. Defer, close the connection. That makes enough sense. Create a buffer to hold the received data. Okay. Okay. I'm gonna investigate this buffer size. I don't know if this buffer is the right size. We'll figure this out. Then we read the incoming data into the buffer. Con.read buffer. Fair enough. And then you write it. Wait a second. Buffer.length. Con.write. Now this is going to be good. Why do we need to read this into a buffer? Get rid of that. Totally useless. Totally useless. Now this is what I'm talking about. No buffer. Just copy it straight over. Why all the indirection? Why all the nonsense? So let's write this file. And let's see where we're at now. Oh, shoot, I need to run the file, run the program, and then run this tester thing. Already, we're seeing numbers that are going crazy. These numbers are going absolutely wild. There's no way that they can compete with these numbers. Look at this. Look at this. We are already at, what was the scores to beat? 13141.7. We're already at 11070.9. That's less. Why is it worse? I wasn't expecting this. It shouldn't be worse. Bandwidth per channel, 220. Bandwidth per channel, 185. Guys, this isn't going to be a fun stream. I don't like this. Guys, I'm not having fun right now. Let's try this again. Maybe there was a mistake somewhere. Nope. No mistake. All right, let's undo all those changes we made. Run this thing again. Yeah, this is quite strange. Okay, so now it's much worse. Maybe my computer was just like cold when I ran this earlier. Wasn't doing as much. Yeah, let's go with that. Anyway, I'm going to go back to what I had before because, frankly, the con.copy, the copy thing should be what works. What is it? Underscore comma error equals io dot copy. What's this in? Copies bytes, the smallest number of bytes, blah, blah, blah. Copy buffer. Okay, so this is stages through the provided buffer rather than allocating a temporary one. Interesting. What if we stop allocating buffers? What if that's where all the power is coming? What if that's where everything is happening? Con, get rid of that. Get rid of that. All right. Error colon equals that. All right, let's. Now that I have a little bit of load going on my machine, I think that's probably what changed the other results from earlier. All right. So we're still doing worse than initially. Doing slightly better than what we just had with the old code. But now it's time to see what's really going on. So one of the things I think is happening, handling the connections in a Go routine. This is just going to spin up as many Go routines as it can. And it really can't do more than how many I have cores. So what I ought to do is just do like a thread pool type deal instead of just spawning a new Go routine, right? So get number of cores, Golang. How to find out the number of CPUs. Runtime.num CPU. Fantastic. So we're gonna import runtime. That's fantastic. Then we're gonna do func start handling requests. Then it's gonna take in a con, a net.con, and then a actually, you know what? It's going to take in a chan of net.con. And then all it does is all the stuff from handle requests when it reads in chan. So you'll just say for c colon equals read from that chan. We're going to call this c. Is that how you do that? For read for no. While for read from channel infinite loop Golang. This is important stuff. Go channel infinite loop whatever. Don't care. For it's for select. Oh, range. Oh. For con colon equals range C. Then what we're going to do is we're going to do all of this other stuff. We're going to defer the con.close. Actually, we're not going to defer the con.close. We're just going to call it con.close at the end. Deferring sounds like a hassle. So we'll do what was this for loop doing? You know what? I just realized something. This is what it should have been. And this new code I just wrote is useless. I mean, it won't be useless later, but for now, we can just do without that. Oh, and of course. Thank you. There we go. So what I've done is just realized I made a terrible mistake. We got into all this branching code nonsense. It was waiting until the error happened before it would do anything. It would copy the whole thing over, and then it would try to copy it again since it was all in a for loop. And we can't have that. So let's try this again. And it's no faster. At least it's not throwing errors anymore. But the number got lower. Why is it slower? What happened? What happened? What happened? Why is it even slower? Did I do something wrong? Successful copy returns error equals nil, not error equals EOF. Buff.io. No, but it's not even a Buff.io thing. It just this is weird. I don't know what's going on. Why is it yet slower? All right, 12,062. All right, fine. So it looks like the extra error that would happen when you tried running this copy again wasn't doing it. So we're just gonna go back to what I was trying to do before. I'm setting up a little thread pool going on. So then it'll read the connections from this channel, and then it will do underscore comma error colon equals io dot copy con. Could be an issue with Nagel's algorithm because this is a very synthetic test. What's Nagel's algorithm? I've never heard of that in my life. Error writing error dot error. And then we will just do a con dot close, and then here we'll do a con dot close, and then a continue. So now we don't have to do an extra call stack thing. We don't have to do that. And then we can just do, so what we'll do is in the setup, we will get how many cores there are and only start that many go routines. So we'll just say for many packets equals slow buffer small packets into one big packet equals faster. Oh, and a Y combinator. I'll check that out real quick. So how was I going to figure out how many? So it's runtime.num CPU. For I colon equals 0, I is less than runtime.num CPU I plus plus. And then we'll say go start handling requests, and then we'll pass it a channel var c, or no, we'll just say c colon equals make chan. And then what were these? net.con. And then each time we get one, instead of going and handling the request in a new go routine, we will just say, we'll just send the connection over that channel. And let's see how fast that works. This should be faster. It's not. It's not faster. It's much slower. This is quite strange. Everything I think is faster is slower. Why? So the thread pool didn't work. You know what? I'm going to do something that I think is slower. I don't even care. We're going to do we're just going to do it single threaded. I think this is going to be really slow. Don't need any of this. Don't need any of this. And this is the fastest one yet. I love computers. Yeah, this is the fastest one yet. Literally didn't even try. Just did it all in one thread. This is beautiful. I love writing code for a living. So we already beat our current record at 15,000 as opposed to 13,000. And all we did was remove all the smart parts. Oh, this is great. So here's what we're going to do next. We're going to get rid of all this error handling because branching code is slow. And we're not going to do this defer because that's going to be a hassle. This print line, useless. Again, more branching code. Can't have that. More branching code. Can't have that. Imports, slowing the program down. Now this is going to be what I like to call speed. This is blowing my mind. Look at the speed on this bad boy. We got rid of those branching codes. Oh, man. This is what I like to see. We have over-optimized the shiznit out of it. Look at this. 16,587.4. Now that is beautiful. Now what else can we do? A for loop is way too slow. So we're going to do a, we're just going to have this thing called loop. And then we're just going to say go to loop. So that should be even faster. We're getting rid of all the bloat. We're getting rid of all the nonsense. This is just going to happen. I mean, this is speedy. This is real code. This is what all the homies do, you know? I mean, this is where it's at. 16,863. All right. So let's keep a tally. So 16,863 is the current time to beat. What more curse stuff can I do? Let's see. Net.listen. The accept. Let's go into the source code here. Listen config lc.listen. What is this lc? Listen config. .listen. This looks like some unneeded object orientation going on. Anyway, sending in a context. Who needs that? Network address. Okay, fair enough. Let's see. Let's lc.listen. Okay, so we resolve address list. Listen. You know what? We don't need to. Listen only gets called once. I want to see this. What's going on? This is accept. So it's a listener interface. So let's go to implementation. Whoops. Space GI. Okay, so there's all sorts of stuff going on here. HTTP serve test. We want this one in net.go. That wasn't it. We want the TCP socket one. So let's go here. And it's in the wrong window. This is really small and difficult to look at. All right, so accept TCP. So we got more branching code. We got to get rid of that. Accept whatever. Return C, nil. All right, so I don't know what's going on in there. This is the fastest one yet. This is insane. This goes crazy. I don't know how much more optimization I can get in this main function here. The next thing to do is probably going to be to profile this thing. So let's just look up go speed profile how to benchmarking in Go. Improving function performance, great. So we got testing, benchmarks, Go tools, dependencies, whatever. Writing a benchmark in Golang, kind of boring. Go test - bench, that's going to be useless. Don't really care. Adjusting minimum time. Where's the one that gets the heat map? Go heat map tool. What's that one? There's one for that. Not this heat map. The Go benchmark pprof. That's the one I want. Pprof. How to profile benchmarks using the pprof tool. This is fantastic. Testing flags, boring. I don't want to do it with testing. I want to do it in. Oh, great. Pprof, go. This is what we're talking about. This is that good stuff. Runtime / pprof. That's right. Package pprof writes runtime profiling data in the format expected by the pprof visualization tool. Let's install pprof. Oh, I already have Alacrity open. terminal.app. We'll do brew install pprof. Ooh, this is good. Net HTTP pprof. This is good. This is good. Okay, that didn't work. By the pprof, install pprof, go Mac OS. This is what we want. We want Google/pprof. How do you get this bad boy in? Oh, you just go install. We'll go install that bad boy. GraphViz used to generate graphical visualizations. I need GraphViz. That's going to be important. Is there a brew for that? Download. Yeah, brew install GraphViz. There we go. This is what I'm talking about. That's that good stuff. Little Ruby, little code signing. All right, this is fun. There we go. There's GraphViz. Fantastic. Great. So now what we need to do is let's run this benchmark for a little bit longer. Instead of 10 seconds, we'll run it for 100 seconds. Except we don't want to do that. We want to do the profiling bad boy here. There's some way to do this. Let's see. Profiling support to a standalone program. Add the code of your main function. Main. If mem profile. Also a standard HTTP interface. That's what I want. Import underscore net slash HTTP slash pprof. That's that good stuff. Profiles can then be visualized with the pprof tool, go tool pprof cpu dot prof. All right, so let's control C out of that, go run this bad boy, and then just real quick we'll do a quick go tool pprof cpu dot prof no such file or directory. What? Profiling data. Adding the following line will install handlers under the slash debug slash pprof URL to download live profiles. That's what I want, right? So maybe I have to do a go func http.listen and serve :8080 nil. So what I'm doing is I'm running a HTTP server, which the pprof tool will connect to and do things that will allow me to download profiles that I can then mess with and look at and do things. So that's going to be great. Let's run the new version, and then we will go to localhost 8080. I believe it's slash, what did it say? Slash debug slash pprof. Slash debug slash pprof. There we go. So we got a bunch of stuff going on. Let's run this. Let's run this little test here. Oh, not this one. This thing. So as this is running, we can reload this, and it should be changing. 8 thread create. Don't know what that's about. Profile. Allox. Okay, don't know what any of that means. Block. Okay. command line, don't know what that's about. Go routine. All right, cool stuff. Whoa, Irish Red Ales. Subscribe for 3 months. Appreciate it. Also, what's with the salt? PJ Salt. All right. Oh, what else do I do? So it can be debug/pprof. Download live profiles. Okay, profiles can be generated with the cpu.prof. More information about pprof. This is good. All right. I don't know where to go to get the pprof stuff. It's just what's happening. Go routines, stack traces of all current go routines, use debug 2. Profile descriptions, allocs. Sampling of all past memory allocations, stack traces of led blocking. Command line invocation of the current program. Sampling profile, this is the one I want. You can specify the duration in the second get parameter. After you get the profile, use the go tool preprof. Alright, so let's go with profile. Is that not downloading? Open like a new tab. Cannot enable CPU profiling. CPU profiling already in use. Okay. Did it make a new thing with the CPU profile? No. Where's the CPU profile? It's supposed to be making one. But where? I'm so lost. Enable profiling. Support for benchmarks. Go test. Equivalent support to a standalone program. If CPU profile os.create pointer CPU profile. Oh, I see. So it downloaded eventually. I don't know what that means. But let's run the... Let's go to a new one of these. Let's make a new... Whoops. Command N. Let's make a new terminal so I can see what's going on. cd downloads. And then what was that file called? That was the profile. All right. Go tool pprof profile. Help. All right, this isn't useful. I just want that heat map. Where's that heat map? That's all I want. All right, web. Commonly used commands include top, which presents a summary, and web, which opens an interactive graph. That's what I want. So let's try this again. Go tool pprof profile, and then we'll do web. And that should have opened up a tab or something. No, this just opened up an Inkscape SVG. All right, so what does this say? Runtime call, 0 of 100 milliseconds. Runtime park runtime schedule, runtime find runnable, runtime net pull, runtime keyvent. I don't know what a runtime keyvent is. This is the CPU profile. See jit.io/jifyum for how to read the graph. Fantastic. Looks like I'm going to jit.io. https://jit.io/jfy. What? Okay. All right. Annotated source code. Interesting. All right, so there's a lot of stuff to this. This is quite complicated. User requests a web interface by supplying whatever web interface provided by the server allows user to actually. So that's a pprof server. Can I just run the pprof server instead of the gotool pprof? If I quit, pprof profile. Oh, so that's the same. Pprof help. So we do pprof dash http. Then we want localhost port 8080, 8081 profile. Missing port and address colon 8081. There we go. So now we got the pprof web UI. Now this is what I'm talking about. Still not all that helpful. Just shows that runtime keyvent is using all the speed. So let's look up runtime keyvent Golang. It's the network polar. So it literally is just sitting there waiting the entire time based on this thing. So what if I don't spend so much time waiting? What if I run this thing immediately and then run this other thing? All right, let's run this thing immediately, then run this, and then while it's running, I will ask for a profile. Types of profiles available, count 0. So it's got no profile already. I wonder how to make it spit out profiles faster. So I think it just sits there for a while until it spits out a profile. Could not enable CPU profiling. CPU profiling already in use. All right, so I already asked for one. Then I will be ready to ask for another. I'll be ready for this thing to set off another go of it as soon as that decides to stop. I mean, these speeds are wild. A little bit slower than they were before. Not by much, though. Anyway, how's everyone in the chat doing? I assume it's the same 3 people that were here before. Appreciate you. The small moose. I got fucking drenched today. Sorry to hear that. You can set the duration in seconds get parameter. After you get the profile, use the go tool pprof. So if I copy link, and I paste it, and then I do and seconds equals 2, will that give me something else? Okay, there we go. So that's how you do it. So if I do seconds equals 10, then it'll profile for the next 10 seconds, and then it'll give me the profile. Well, this is fantastic. This is good news. Also, check that post. I will check that post. But first, pprof, HTTP, 8081, profile 2. So this one should be interesting. There we go. Now we got some stuff going on. Look at that. Look at that. So we are spending most of our time in syscalls. Syscall read, syscall write, syscall read, or syscall write. And frankly, almost nothing else is happening other than syscalls. So we got this IO copy buffer is taking 77.85%. So the IO copy is, oh, I see. So IO copy buffer, literally all of the time is spent in syscalls. Like literally all of it. So then the other rest, we have this runtime call, runtime park runtime schedule, runtime is runnable, net pull. Okay, so we are either waiting, which is almost no time. We are handling a signal, which is also almost no time. We are runtime keyvent, which is just polling, which is just waiting. And then most of the vast majority of our time is in syscall.syscall. So I'm trying to think, how could we, A, speed up syscalls, which would be beautiful, or B, convince these syscalls to just happen less. But really, with all of our time being spent in syscalls and waiting for more connections, this is, between these two, it's like what, 98.5%, 98.6% of our time. How is it that anything could go faster unless they're doing something? Like, is there some dark magic for copying one buffer into another that doesn't involve a syscall? I guess it's not even copying a buffer into another. It's copying well, you're just writing to the socket and reading from the socket. That's what that syscall is, that read and that write. I don't know that this can be optimized. I think this is about it. Like, we can squeeze out some small portion of that last 1% that's not being done. But like, I think we've hit a limit. Unless, of course, we run this on another computer. I legitimately am not sure what's going on. Let's check this Y Combinator that Moose is talking about. Golang disables Nagel's algorithm by default from a year ago. Golang is evil on shitty networks. Yeah, I don't think this has anything to do with anything. This isn't happening over an actual network. Let's see. RSC himself replied. That code was an internal loose port of the dial function from Plan 9 from user space, where I added TCP node delay to the connections by default in 2004. Then helpful commit message for various weeks. If I had known this code would eventually be of interest to so many people, I might have had a better commit message. I do remember why at the time I was working with a variety of RPC-based systems. I ran over TCP and I couldn't understand why they were so incredibly slow. The answer turned out to be TCP node delay was not being set. As Nagel points out, the issue is a really bad interaction between delayed acts and Nagel's algorithm, but the only option on the FreeBSD system was TCP no delay, so that was the answer. Another system I built around that time, I ran an RPC protocol over SSH. I had to patch the SSH to set TCP no delay, but at the time the SSH set only for sessions with PTYs. Now, TCP no delay being off is a terrible default for trying to do anything with more than one round trip. When I wrote Go implementation of net.il, which I expected to be used for RPC-based systems, it seemed a no-brainer to set TCP no delay by default. I have a vague memory of discussing it with Dave Prosetto. Blah, 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 blah. And then it makes sense that get LFS Should be sending large files, 50 bytes at a time. That's a huge number of system calls that could be avoided by doing larger writes, and then the larger writes would work better for the TCP stack anyway. Yeah, so this is interesting. He mentions that there's a large number of system calls, which, if we look back at our thing, we are doing a large number of system calls. So, unironically, we can improve throughput just by, like, doing more work. Like, if we just, instead of sending a hello world, if we sent a whole bunch more stuff, let me go back to 10 seconds because 100 seconds is too long. Then our numbers should go up considerably. Start at 19, 15, 16, as opposed to what it was before, 13. Start at 22, maybe not. Maybe it's that copy syscall that's taking all the time. I don't know. 15.682, 16.863. You know what? That didn't do much. Anyway, let's get back this thing back to hello world. So the question is, do I put a pull request in with this this ridiculous simple main and just totally ignore the fact that it's considerably worse than the original? That's the real question. Because it is much faster. Will not accept. The syscall thing's interesting. Is it? I mean, you're just reading on a socket and then writing on a socket, which are both going to be syscalls. I mean, we can look up speed up socket read and write Mac OS. Nope, nobody cares. Nobody cares about sockets. All right, great. They're just talking about drives. So all I want to know is if this thing gets similar. Well, it's going to be similar in Rust, clearly, based on that. But how would Elixir, Erlang, EU, and Atacama get around all the syscall heck that's just going on, that's slowing everything down? That is what I'd like to know. Because let's see, if I do, let's just go back here to where we were. So, all right, EO is real slow. But if we look at Erlang, I want to know, or Elixir, how is Elixir so much faster? Elixir echo, is this? All right, I don't know what that means. Lib echo def module echo do 1000 island dot handler 1000 island dot handler data handle socket state continue state. Use application impl true start children 1000 island application dot fetch env. I don't know anything about this Elixir stuff. net.inet.tcp.send space. Let's look that up. Interesting. sysctl minus n net inet tcp receive space tcp send space. All right, so I'm gonna not do this because I'm currently using TCP sockets right now, like for this very stream. But this is interesting. Elixir's version, basically all that handle data callback, gets the data and sends it back. Doesn't handle bad sends, for what it's worth. Well, if it doesn't handle bad sends, then I should open up a pull request. Because this doesn't handle bad anything. You know what, just for funsies, let's do some fun stuff. Let's open up terminal, and then another terminal, and then we will do a, we'll go run echo.go, and it's listening on, oh, I forgot what that port was. Echo.go, listens on fmt.println, listening on 2112. We'll go run echo.go. Then we will make a new terminal window. Why not? And then we will do, what's that thing? Telnet, localhost 2112. Hello. And it's echoing back. How neat is that? So it works, clearly. What did I say the escape character was? Control. Oh. Oh. Run shell scripts over here. Yeah, I'm just going to terminate this. Anyway, I pulled up my password handler. So yeah, so echo.go works great. We're getting trapped in syscall land. There's really nothing else we can do. I want to know how this thing gets around that. Maybe it's different on like a Linux system. Maybe Linux doesn't get so trapped in syscalls. I don't know. Could that be a thing to worry about? Like, what else would it be? Because, I mean, Go is doing almost nothing. It's less than 1% of the runtime is spent doing actual Go code. Everything else is, you know, going to be language agnostic, send and receive stuff. I mean, before half the time was just spent in, not even half the time, probably some significant percentage, maybe 10% of the time was spent in wrangling all those Go routines. I'm guessing it's down to how the packets are chunked. Well, each one of these should just be one packet. Is there a way to tweak the TCP performance in Go? All right, this is a little useless. Ooh, there's a fast TCP package. Highly optimized TCP listener server system for Golang, taking inspiration from the performance and TCP listen and the Go blocking server in Volley. Standard runtime library listens for new TCP connections on one thread. However, the Linux kernel versions can allow multiple threads to serve connections simultaneously. This is done with the help of this project. This alternative TCP listener also supports the use of TCP defer accept flag. Interesting. TCP fast open, which will set up the socket to send data before the ACK is received from the client. Well, this is all Linux stuff. I want to know what machine this person was running this on. Because maybe in Linux it's different. I mean, are Linux and Unix that different? Let's just FYI, it's hella fast on my Linux desktop, 800 megabit per second. All right, let's cd source, cd github.com. We will download git make dir leostera, cd leostera, git clone https github.com leostera Atacama. All right, so we'll cd to Atacama, cd to bench, and we will, what was the name of that program I was running? TCP Kali. Sudo apt install TCP Kali. TCP Kali? Ubuntu. How do you install this in Ubuntu? Does it not? So it has a Nix env thing. I don't know how to do that. FreeBSD, Mac OS. They don't have the thing. Jordan Forge, but I'm getting stuck with Erlang errors. Can't compile anything to compare it against. Oof. Irish Red Ales. Turns out Fedora and MySQL are not homies. Well, you know, it's better that you found this out sooner rather than later. So why can't I get this thing on a non-Nix system? Like, oh, I could do all this. Let's see, TCP Kali Ubuntu. Yeah, this is fun. I love having to go through dependency like stuff. Like I love it when stuff isn't in my I must attend ye old networking stuff. PST time zone meetup. All right. See ya, Moose. So we'll make dir Satori com, and then we'll git clone github.com/satoricom/tcp Kali. Then we will cd to TCP Kali, and then we will run, what is it? /configure test -f configure pipe or auto reconf it, whatever. I'm just going to copy this and paste it. Great. Make libtool bison flex gcc-c++ incurses devel. All right, so not these two. Ooh. So we are going down the rabbit hole. We are going to get this bad boy going on Linux and see what we get. So what were the ones that didn't work? I'll just paste this thing again. Okay, so things are coming along. Things are coming along. Okay. Error. Newly created file is older than distributed files. Check your system clock. Thursday, December 28th. 2:01:49 a.m. UTC 2023. (2:02:10). Okay, so my system clock is exactly correct. So that's fun. I don't know what's wrong with this. At least one source file is in a subdirectory, but the subdir object's automake option hasn't been enabled. For now, the corresponding output object files will be placed in the top level directory. However, this behavior may change in the future. Huh. So that's broken. I don't think we're going to get this running on Linux. So where do we go from here? I rewrote it, and it's perfect. And that's about it. Don't really have much more than that. How long have I been going? A little more than an hour? All right, chat, you decide. What do I do now? Chat? You decide. What do I do now? All right, good stuff. Chat has, wait, set up a MySQL connection on Fedora Rawhide. Shoe on head. Irish Red Ales, are you having trouble setting up a MySQL connection on Fedora Rawhide? Is that what's going on? Would you like me to just solve your problem for you? Did I say Rawhead? Yeah. When you say set up a MySQL connection, where are you running this MySQL instance? I'm not saying who are you running it as. I mean, where is it running? Is it running? So you're trying to connect to a Fedora Rawhide. You're running Fedora Rawhide and you're connecting. Okay, so you're running it on localhost and you're trying to connect from localhost. Okay. Well, once Docker updates, so that should only be another 45 minutes, we can get this thing going. Let's update this thing real quick. This will only take about 45 minutes. Installing update, verifying Docker.app. Oh, Docker. Wow. This is my favorite application. When I want my computer to be running slower. I'm in love with Docker. In fact, if I were to say there are two things I was in love with, it is Docker and the Cocoa. Anybody in love with the Cocoa? Remember that song? Yeah, me neither. Oh, it went away. Where'd it go? Ah. 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 It's back. Not in love with the Cocoa yet. Still in love with the stripper. I'm in love with a stripper. All right. So let's get an image. Let's search redo through the hub. Let's go for, what's that thing called? Fedora. No, not in npmail. I just want it all over the place. Is there no way to search Docker hub? I don't want just my images. Where are the good images? Volumes, images, containers, extensions, Docker Scout, advanced image analysis, dev environments, volumes. Does this thing have settings? Did it say something about? Hold on a second. First of all, use Rosetta. Oh boy, that'll be fun. All right, so let's get back to cancel my settings, search. We want Fedora. Docker images, Fedora :23. So we'll open up a good old Alacrity. And it showed up on the wrong window. So that's fun. Love to see it. Oh, hit the wrong set of keys. There we go. So we want to Docker run -it Fedora :23. Oh, you'll find image Fedora 23 locally. Oh. Enter login keychain password. There we go. So we're getting Fedora. Error response from daemon, no command specified. We want /bin/sh. Perfect. Let's run bash. Perfect. So, is this the, yeah, dnf, install MySQL. So this is coming along. Anybody read any good books lately? All right, good. Okay. So for some reason it didn't like it. There we go. Now it's downloading packages. That's a bunch of stuff. So we got that. Now let's run MySQL. Cannot connect to MySQL server through socket. Sudo apt. No. Systemctl enable MySQL. systemctl enable MySQL. Systemctl start MySQL. Sudo systemctl start MySQL. Jordy LaForge, I watched the new John Wick. Pretty good, right? I like the new John Wick. The John Wick playing dead and then actually dying. Except maybe he's not dead. Ooh. He did. Allegedly. But who's to say he's actually dead? So when you install MySQL, it's saying distrib MariaDB for Linux. This isn't even real Oracle MySQL. I mean, it says Oracle, but I don't think it is. MariaDB Corporation. Is this what you're having problems with, Irish Red Ales? You think you've installed the full-fat Oracle MySQL when in reality you've installed MariaDB? What do you mean you got past this? This was the first issue. What was the first issue? Oh, you install the community server. All right. Anaconda KS.cfg. No idea what that's about. Anyway, you install the community server. So DNF install MySQL what dash something. My tab completion's not working. What's fish about? Okay, so there's a lot of these bad boys in here. MySQL utilities, bunch of stuff. MySQL, tickle MySQL. Anybody ever write tickle? TCL? Good language. MySQL writer for libgda. MySQL copy. MySQL support for urslslog. Nodgus. Postfix. Soki. Ermsk. MariaDib. Ooh, I like the idea of this. This one looks good. Dinf install MariaDib. Fantastic. So what's this fish shell about anyway? Hostname. Help for instructions on how to set up fish. Well, it needs a browser. We'll do export. We'll do dinf install w3m export browser equals w3m dinf install withram. What was I trying to do? Oh, run help. Okay, so what's this fish thing about? Have you guys ever used fish? Kind of over it. Anyway, this stream has gone off the rails. I ran out of things to talk about, and all my other projects are in such disarray that I can't work on them. I've always thought it's my ZSH with even more training wheels. Yeah, that's what it looked like to me. I mean, it has all the stuff that I already configure in my ZSH, so it's like, what's the point? Who cares? Anyway, I think I've streamed enough for today. I think I'm gonna quit Docker Desktop, and I think I'm gonna, walk away with pride, knowing that I was able to stream for over an hour when I had nothing. 20 minutes before I started streaming. And I'll have to get some other projects into a good enough place that I can work on them on stream. Thank you, those of you stuck around, and I will see you next time.